Okay, welcome. This is your lesson on your interest-based problems. You have a handout in front of you. I encourage you to get out your notes so you can write a couple things down here. Your goal today is you can determine which interest formula to use to correctly solve our finance problems. So the first thing I'd like you to write down is this compounded continuously formula. Sometimes they compound interest continuously, and this is the formula. A is your amount, it's what you end up with. P is your principal, it's your starting amount. E, it's Euler's constant, it's the button on your calculator. It's equivalent to 2.71 something. You're going to use the button on your calculator. R is your rate as a decimal. T is your time. I'd like you to pause this right now and make sure you write down this formula and what all of its values are. When you're ready, come on back. Okay, you're back. Here's our next formula. It's for compounded, it's when interest is compounded periodically. So it looks a teeny bit different. In place of E, we've got something with a fraction inside parentheses there. But truth be told, it's A is still our ending amount. That works out just fine. P is our principal, or the amount we originally invested. R is still your rate as a decimal. T is your time in years. What's different here is we've got a variable n. It's the number of times you are compounding. The number of times you are compounding. You can pause this if you need to write this down. We're going to add what our compounding times might be. So if we compound once, might be the word annually. You'll see the word annually, and that means n is 1. If we tell you we're compounding semi-annually, that means n is 2, twice a year. If we compound quarterly, that's n equals 4. If we compound monthly, that makes sense. There's 12 months in a year. If we compound weekly, that's 52 times. If we compound daily, guess what that would be? You're right. N equals 365. Okay. So let's look at the first problem on your handout. What we're going to do is figure out which formula to use and set up an equation. So this says we're investing $5,000 in an account that earns 3.5% interest compounded quarterly. What is the total amount after 3 years? Okay, so what I would love for you to do is highlight what I've highlighted, and these are the key things that you should look at. Since we're compounding quarterly, this means we're going to use the periodic formula. So that formula is going to be the A is A is P1 plus R over N to the N times T up there. So it looks like what we're starting with is my principal. That is $5,000. And it looks my rate is 3.5%. When you turn that into a decimal, it's 0.035. So take 3.5, divide it by 100, and that's how you get that number. My time here is 3 years, and it says I'm compounding quarterly. Well, that's 4 times a year because there's 4 quarters. So the way that we solve this is we say, how much money do I have if I put $5,000 in 1 plus 0.035 over 4 to the 4 times 3. Okay, so I'd like you to get a couple figures in your calculator first before trying to put this all at once. So what we'd like to see, especially when you assess, is I want you to take this here, take 0.035 and divide it by 4 in your calculator and add 1 to it, and then I want you to write down 1.00875. That's what you should get. And then I want you to go ahead and take 4 times 3, and that's 12. This is the line that you enter in your calculator. So when you plug that in, you end up with $5,551.02. Okay, so that's how you solve that. Okay, next one. This one, we've got $10,000 that we're investing in an account. It's earning how much money? It's earning 5% that's compounded continuously. What's the balance in the account after 6 years? So in this problem, we're going to use PERT, PERT, because it's a continuously compounding. And this says, what's the balance in the account after 6 years? So for this problem, my principal is $10,000. My rate is 0.05%. My time is 6 years. So I'm going to set up A is equal to 10,000 times E to the 6.05. So 10,000 E to the 0.3 power. That's what I'm going to type in my calculator, and I get 13,498.59. Okay. Okay, this one is a little bit different. How long will it take to double in value? Well, if I start with 10 grand and I want that to double, that means I end up with 20 grand. And I'm asked to solve for time, so that's my I don't know. So I get 20,000. That's what I want in the end. I've originally put in 10 grand. That's going to be E to the 0.05, and I'm solving for T. Okay, so divide each side by 10,000. We want to get E by itself. So I get 2 is equal to E to the 0.05 T. Okay, so we all know how to convert exponentials, so this is pretty easy. I'm going to write this as the natural log of 2 is equal to 0.05 T, and the natural log of 2 is going to give me some number, and I'm going to get that number and divide by 0.05. So my time ends up being 13.86 years. So 13.86 years for me to double in value. Okay, your last example is going to be this one where your aunt bequeaths you some money when she sold her house. That's pretty nice. So I'm going to erase this over here and give myself some room. Okay, so it looks like she's going to give you $2,000, and you're saving for a car which costs, and there's an account earning 5 1/4 compounded monthly. You are solving for time. How long will you have to invest? So if we start filling in what we have $2,000 to start with. We want to end up with $15,998. Since we're compounding monthly, that means 12. Our compounding is 12, and we're earning 5%, 5 1/4, 0.0525, and we're solving for time. So 15,998 when I start with 2 grand, and I'm going to do 1 plus 0.0525 all over 12, and then this is going to be to the n times t, 12 times time. So what I'd like you to do is figure out what this value is going to be in your calculator first. It helps eliminate error. So 15,998 equals $2,000 times, I got 1.004375 to the 12t. So we're solving for time here, which means I'm going to probably have to convert this to a log, but the first thing I need to do is get that base by itself. So when I divide each side by 2,000, I end up with 7.9999 is equal to 1.004375 to the 12t. Well, you guys, this is exponential. I can turn it into a log. What number is my base? 1.004375. What number is my argument? 7.99999, and that's going to equal 12t. So I'm going to put that in my calculator. I'm going to evaluate it and get a number, and then I'm going to divide that number by 12. So I end up with 12t equals 476.33 when I divide by 12. My time is 39.7 years. They won't even make that car. That's ridiculous. Okay, so pause, rewind, do whatever you need to. The solutions to the rest of your problems, just the answers only, are going to be posted in here, and I will put up a worked out key eventually. I wish you luck. If you have any questions, rewind this video. You can go to tutoring or send Miss Mendegral an email. Thank you.